Good morning, everybody. So this week is class 6, and this is going to be our last week of learning the fundamental tools for rigid body simulation, RBD simulation. So today we're going to talk about painting glue strength, among a few other things, like creating a project folder as item 2 here. Item 1 is where we're going to review our tutorial assignments. I'd like to see what everybody came up with from last week. We'll have to try to push through that quickly because there's so many of us. But also, I just want to point out, my wife has been in at the hospital since Friday for something, not COVID or anything like that. It was a surgery she had to have. And I'm supposed to go pick her up today. I was supposed to pick her up this morning. And because of that, I did an asynchronous class with my morning class, but now she's not coming home this morning, so it might be this afternoon. Right now, I'm still planning on us meeting together at 1 o'clock in Teams, but I will let you know if that changes. So just keep an eye on the announcements. So as of right now, we are still planning on meeting at 1 o'clock in Teams, but that could change. If we don't meet in Teams today, then we won't be able to review this assignment. We'll maybe try to review it next week, although we have an assignment for next week that I would want to review next week. So this one might just go unreviewed if we can't meet face-to-face today. So again, keep an eye on the announcements for whether we're going to meet face-to-face today at 1 or not. But as of right now, we are. So as I said, we'll do project folder structure. I want to talk about that. And then we're going to do painting the glue tolerances. And to prepare us for next week's assignment, I want to talk about importing geometry, in particular from Unreal Engine. But this is probably the same with most game engines. And in particular, what we need to worry about is the collision geometry. When we export an FBX from Unreal, I'm not sure how Unity handles it, but from Unreal, it will export a collision mesh also. Now, as the name just suggests, it's for the player colliding with the object in game. And it's usually just a giant kind of box around it. And in Unreal Engine, that is prefixed with with UCX. That designates what's collision geometry. And that's how it reads it. So we need to get rid of that. So we'll talk about that. And then that brings me to our assignment. So what I'd like for you to do for next week is find an asset for destruction. It can be an asset of your choice. You want to be careful, though, not to choose something that's too high resolution, because it will really bog your simulation down. There's ways around that with high res geometry, but let's keep it low res. We know we're working primarily for games, so my suggestion would be to export something from one of the game engines like Unreal Engine, which is what I will use as an example here. So you want to export or find that asset. Now remember, we're doing rigid body, so you also have to keep in mind what the content is. This is a rigid body destruction, so you want to choose something that would fall apart like a rigid body. And we also, most of the shaping methods we've learned play more into things that are made out of solid objects like stone or maybe brick, those types of things. You don't want to do a rigid fracture on like a computer monitor, for instance. That just wouldn't really work. It wouldn't make any sense. A computer wouldn't break apart in the way that we know how to fracture things. Again, I keep saying we've only scratched the surface on rigid body fracturing. Certainly there are times where you need to break something apart, like a computer monitor. And we need to apply some different tools there, even though it's still a rigid body simulation. So for the sake of time this semester, I gave you just the basics, but it's enough for you to go off and learn the other tools that you might need to do something like fracturing a computer screen. But for this assignment, for your simulation to seem believable, you want to choose subject matter that makes sense with the type of fracturing we're doing. And again, our fractures look mostly like they would be stone walls or marble, solid objects, basically. I think even like a house, I guess if a house was made out of stone walls, or a structure with cement walls, that would make sense. But you don't want to pick a colonial house that has wood siding. It wouldn't come apart the way we know how to shape our fractures right now. So keep that in mind so that you can create a believable simulation. So what I said here is I like you to take a first pass at destroying it using the tools that we have at our disposal. If you've done additional tutorials, or if you find something that you say, I really want to fracture this object and it's made out of wood, you can find tutorials for that. So that's fine. But what I don't want to see is I don't want to see a piece of wood that fractures with a regular Voronoi fracture and it crumbles apart as if it's made out of stone. So these are the things to keep in mind as you're choosing your content here. Now I call it the first pass because this is actually what we're doing here is we're preparing ourselves for one of our individual projects. And if you look at our syllabus, oh, I already had the syllabus open right here. On the syllabus, we have two individual projects, a rigid sim and a pyro sim. So this is our first one. So we're going to do a first pass at it, and that first pass is going to be worth 5 points. So that's chipping away at these 25 points for the rigid simulation. We're doing a first pass, probably even a second pass, because we need to review these. We need to review them for believability in order to make them better. And also there'll be lots of questions on how to solve your various situations that you might encounter with your rigid simulation. So we want to take some time to really plan and map this out and make it look really good, because ultimately it needs to be a piece that you put into your portfolio or demo reel. So we're going to be working on this in multiple phases. All right, so with that said, let me come back here and let's start by just talking about creating a project folder structure. And the reason I want to talk about this is because we're also going to start to get into disk caching. And also, actually, it makes sense for this project because you're going, or this assignment for next week, because you're going to be bringing in, importing a model. And Houdini does not contain anything imported directly in the Houdini file. Like for instance, in Maya, if you import an FBX, that FBX geometry is contained in Maya, unless you go through extra steps to make it a reference. But if you don't and you just do file import, it's in Maya. It's in the Maya file. You can take the Maya file with you somewhere else and that FBX is in there. Houdini doesn't work that way. Everything you import is external. So if you lose that path to the object it's referencing, it's going to give you an error. So we need to know how to set up a project folder. So we're going to start with that. So let me move this out of the way here. And I have a file already in Houdini. Excuse me. So if we look at this, it can be as simple as this. There's really two ways to do this. We have if I go to the file menu, I can do new project. And that will create a project folder structure for me. But actually, and I have this mapped out this way in the lesson plan, but I think I want to show you the simplest method. So the simplest method is that on your desktop, so actually let me move Houdini out of the way here. On your desktop, I'm just going to right click and create a new folder. And I'll call this my project. I'm just creating a new folder right there. I'll go ahead and open it. And it went on another screen. So it is, it's empty. Obviously, there's nothing in there yet. So when you before you start importing objects into Houdini, what you want to do is save your Houdini file into your newly created project folder. So I'll go back to Houdini. I'll go to File, and I'll do Save As. And I'm going to save this. I'm going to go to where I am here, Desktop. Let's see. What did I call it? My project. Here it is. So I'll go into there, and I'll give it a name. So I'll call it, also call it My Project. Okay, so again, if I look at that folder, I now have a Houdini file in there. So now I can start importing. So what I would do is I do File, well actually, sorry, one more step. You want to put your file in here. So for instance, if you exported an FBX from Unreal Engine, you'd want to put it into this folder. You want to put it in this folder here. Let me see, I'm going to put, what do I have here that I can use? You know, let me pause for a second and let me just get an FBX. Okay, so I have, this is actually one of our models for our upcoming Opera project. It's a Bluebird. So you can see I actually did export this from Unreal Engine. So this is Bluebird from UE4.fbx. Okay, so now I'm going to go back to Houdini. I'm going to do File, Import, and I'm going to import, I could just do import geometry. This is sort of the catch-all, but if I know I'm importing an FBX, I could just go right to the FBX import. Either one would get us there. Now this is, can I scrunch this down? There we go. So now I just need to browse for the file. So I'll hit the browse button right here. And this is the important thing here is we want to, whenever you import something, you want to import using this reference. This is highlighted by default, but just make sure it is. It says $hip. What that is that's basically a string variable. And what it's doing is it's saying, look in the folder where the Unreal, and I'm sorry, not the Unreal. Look in the folder where the current Houdini file is. So the Houdini file I have open in Houdini right now, this is saying, look in that folder. If I do anything like this, like if I go here and I go Desktop, My Project, Bluebird, this is not going to work. This is going to give us, if we try to take this somewhere else, if we don't have this exact path, then it's not going to find it. But if I do $hip, it's a relative reference looking in the same folder, project folder, where my Houdini file is. So then that way you can just take that project folder anywhere and it doesn't have an absolute path up here to a drive number or anything. So again, we do $hip, I'll select the Bluebird and hit accept. And I don't need to change any of the options in here. I'll just do, I don't want to import as a new scene. I'm going to import it right into this scene. So I'll just hit import. And there is the bird. So if I look at the import here, so when you use file import, it's going to place it into what's called a subnetwork, which is basically, it's just a container. And if I go inside there, I can find all the pieces. Now this has rigging on it. So all of those pieces are in here. These are all the joints. Let me see if I can find where the geometry is. Geometry's got to be here somewhere. There it is. There's the geometry node. Oh, actually, I need to find it up here. I'm looking for where it has the path. Where is the path? One of these nodes should show me the path to this. Oh, that's interesting. Where is it? I actually don't import this way. So, I mean, you can do that, but let me show you another way to import also. All right, let me remove that. All right, so another way to import is just to create an empty geometry node. So I'll do geometry, make a geometry node. Then I'll double click to go in that geometry node. And then I'm going to right click and do import. And then I'll just choose file right here. And then over here where it's asking me to browse for the file, I'll hit the browse button. Again, I'm doing the $hip reference. Hip means Houdini file. And then I'll select the object and import it. There we go. That's better. I also get a cleaner graph. So actually, in this case, it gave me the geometry, but not the joints. So if you wanted to bring in a model that's skinned for whatever reason, you would want to use File, Import, FBX. But in this case, I just wanted the geometry. So I just did an empty geometry node and then put in a file import. Now you can see it is its path is $hip and then the name of the file. So that's a relative path. That's extremely important because if you don't do it this way, or you import it from somewhere outside of the project folder where the Houdini file exists, you're going to create an absolute reference. And then if you take that project folder somewhere else, you're going to lose connections to all of your imported assets. So that's what you want to consider with building a project folder. And again, I gave you what I think is the easiest method. You can do the file new project, and this is much like creating a new project in Maya. It'll make a bunch of subfolders for you that Houdini typically likes. But I found that most of the time I don't use this method. When I'm getting ready to work on something, I make a folder, I save my Houdini file into that folder, I put my assets in that folder, and then I import them from within that folder using a relative reference. All right, so keep that in mind as you're getting ready to import geometry. So let me remove that. And let me come down to painting glue. All right. So right now what I have here is I have a box that, how am I doing? I think I'm okay on time. You can't see the geometry because I already, oh no, what am I thinking? No, I didn't. It's not packed yet. But you can see, so it's just a Voronoi fracture. I didn't paint the fracture in any way. I just did a volume fracture and that's it. And then I also have a ball, a sphere here that has a transform node that animates it. So it just passes through the wall. So what I want to do is I want to use glue to help shape this wall, parts that will stay together while other parts will fall apart. So we looked at the glue constraint a week ago or so, and we just simply used it to hold the object together and then let it fall apart later on. But we didn't have any control over how those glue bonds were all one strength. But we can paint the strength so that it's weaker in some areas and stronger in others. So here's how we do it. Again, there are a multitude of methods here. You can set this up from scratch, which would be advantageous if you've already built this wall into a rigid body, because the tool I'm going to show you here, the shelf tool, which is this one cannot be used on geometry that is already in a simulation. So if we already turned this into an RBD object, we can't use this. And in that case, we need to build our glue network from scratch. I have a video on my YouTube channel that talks about how to build your glue constraints from scratch. But again, I want to keep this class streamlined. So I'm going with the fundamental quick shelf tool methods. So when you're planning your destruction, knowing what we know here, you need to plan ahead. You have to think about, am I going to use glue constraints or not? If you know you're not going to use glue constraints, then you can just do an RBD object. If you are going to use glue constraints, then you need to use this one. So it's either or here, this one or this one. We can't do this one first, then add this one later. So this one basically will set up the glue network for us. What it does set up, you could set up from scratch yourself after you've created an RBD object. As a matter of fact, there's been times where, not necessarily with this, but something similar, let's say I set up an RBD simulation, and then I decide, oh, I need to add glue to this. So what I do is I just go over here and I make a new simulation, and I use the RBD glued object to get the nodes I need, and then I just copy those nodes into where I need them in my current network. So, we can hack and slice this stuff up too. So in this case though, I have not made this a simulation, so I can use this shelf tool, and that's what I'm going to do. So I have my box selected, and I'll click on the RBD glued objects. And in here, it makes the additional glue constraints. And the glue constraint right now is set to 10,000. So what we're going to do is we're going to paint the strength, though, over in the geometry network. And that becomes a multiplier against this value. So once we paint those strengths, we might have to do a little bit of manipulation between adjusting this value here versus the value that I'm painting with. So let's go over to the geometry. And here is my glue constraint. It comes off right after the rest node. And what we're going to have to do is we're going to have to add 2 nodes here right after the connect adjacent pieces. Remember, the connect adjacent pieces, that is the glue. Right there, we can see it. So the first thing I need to do is I need to add a paint. And I'm going to add what's called an attribute paint, because we're painting an attribute. We're painting the strength attribute. So I'm going to right click in here, go to attribute, and choose attribute paint. If I can find it. There it is, attribute paint. And I could name this paint glue strength, paint glue strength. I'll put my cursor on it, or my display flag. And the first thing we have to do before we start painting is we have to tell it what attribute to paint. So we're going to go to the Attributes tab. And in the Attributes tab, I want to paint not a mask, but strength. Make sure you spell that right, because that is the attribute. It's looking for the attribute called strength. The glue network is. So that cannot be misspelled. So let me make sure I'm spelling it right. Strength. Yeah, okay. And it should be a float. It's a float value. It's a number. Because we can paint other things here like color or an integer, but we want to keep it as a float. All right, so now I'm ready to start painting. So I'm going to come back to my brush tool now. And in here I have a foreground and a background. So right now it's set to the solid, it's set to the background color. Actually, the way I like to paint is I like to make all the strength 0, which should be purple. But just to double check, I could set this to 0, the foreground color. And under shape, I'm going to choose fill. That means if I come over here and, well, I'm going to use my middle mouse button to make the brush a little larger. If I click, it should flood fill it with 0. Just to double check that, I'm going to make it 1 and let's see what happens. There, see, it becomes all red. All right, so if I make it 0 and click, now I have filled it with 0. So that means that all of the glue strength is 0. Even though it's 10,000 over in the DOP network, that's multiplied by this number. So 10,000 times 0 is 0. So these won't hold together at all. So now what I'm going to do is set this to 1, the foreground float, and I'm going to change my shape from fill to volume. So now I have a volume paint tool, and for some reason that one's a lot larger. So let me make it smaller. And I'm going to paint down in here, and you can see the strengths values painting, and I'm going to come right up the side of the wall here, just like that. So now I have a value of 1 decreasing to 0 over the surface. If you can't see this, if this visualization isn't working, you can toggle this button. This is your visualization button right here. And also I wonder if in our display properties, there's that other one under visualize. Okay, soft fall off doesn't matter here. Okay, so that's fine. Yeah, so this should allow you to visualize it. All right, so now I have a strength of 1 here and a strength of 0 in here. Now I need to add one more node in here, because the connect adjacent pieces, the glue actually happens at the primitive level. And when we do an attribute paint, that's basically point level. It's like vertex painting. So what we have to do is we have to promote this data to the primitive level. And that's just done simply with what's called an attribute promote. So I'll right click again and go attribute and choose promote. There it is, promote. And in my attribute promote, I have to say my original class is a point class because I painted on points. And I want to promote this data to the primitive level. And that should take care of it. Why is that giving, what is this little warning for here? Output attribute name not legal. Output attribute name. Oh, and also this is probably why it needs to know what attribute we want to promote here under the original name. So this is being slightly cut off, but I'm going to choose strength. There, and then the warning went away. Completely forgot that. So we're promoting the attribute called strength, the strength data, from the point level to the primitive level so that the glue constraint can use it. And then I should be good to go here. And don't forget to put your display flag back over in the DOP import because that's where the simulated geometry or simulated points are coming back in. All right, so now go back up to the top level and I'm going to put down a ground plane just for this to have something to rest on. And let's see what happens by default here. Well, actually, probably nothing will happen. We had one little piece pop out. The sphere is also not part of the simulation yet. So I need to make that a static object so that it helps push this simulation along. So I'm going to select the sphere and I'll make it a static object. Now it's still not going to work because remember, I think I showed you this last week. I almost forgot about it myself. In the DOP network, this static object, the sphere, needs to have the use deforming geometry checkbox activated because it's animated. So I have to check that. And now let's see what happens. There we go. Now it falls apart. And you can see what's happening here is see how the pieces on this side, right when it breaks, see how these pieces stay together longer because they have a stronger glue strength on them. Now they may end up, do they fall apart when they hit the ground? Nope, it still stays together. It's still staying together in the ground there. Yeah, so that's what I want. So that's another way to shape your simulations. And this can certainly be used in conjunction with the attribute paint where we painted color. Or I'm sorry, not the attribute paint. We use the RBD paint. This can be used in conjunction with the RBD paint that determines where there's more fracturing and less fracturing. And then you can come through here with glue constraints and paint those to determine what stays together and what doesn't. Now, the next thing I'm going to do is I'm also going to combine this with active and inactive because I want the base of the wall to not fall over. See, the whole thing falls down now. So I want to keep these pieces that I painted not only together, but upright. So what I can do here is use the active and inactive method up in the geometry network to hold these pieces together. So I'm going to go into my box object. And remember, this needs to be done after the assemble node, after the geometry has been packed right here. So I'm going to do an attribute wrangle. This is just reviewing what we did last week, actually. And this one is all active. We do all active first. And I'll just say I at active equals 1, semicolon. I at active equals 1. All right, and then I need to make a group to tell it what stays, what's going to be inactive, I should say. So I'll do a group node now, group, and this is, I'll call it inactive GRP for group, and I'll also name the group inactive GRP. And these are, we want to make sure that we're working at the points level, not the primitive level. All right, so now I'm going to put my display flag here and figure out what's going to be inactive. So I'll do the keep in bounding region, and I just want to run this across the base. And we know that all of this is glued together, So I probably only need to run this over a small portion of all of this geometry, but just to be safe, I'll push it out to the end. Just right at the bottom there. And because of the glue strength, that should hold this side in place also. All right, and then one more node, I need to tell the points in this group to become active now. Or inactive, sorry, inactive. So I'll put down another attribute wrangle. And this will be inactive. PNTS for points, inactive points. So on this node, we want to use the inactive group, the points that are in the inactive group, and those points we're going to say the integer at active, the active integer, equals 0, semicolon. All right, and then I'm going to put my display flag back on the DOP import, and let's see what happens. There we go. Nice and easy there. So all those points that were glued now stay together. And upright. So I've combined glue strength and active and inactive to get this rigid simulation. So you can see we can do a lot of stuff with this. A lot of stuff. Just with what we know. But like I said, I very much encourage you to go out and do more rigid body simulation tutorials. Again, like I said, if you want to, if this simulation that you want to work on for next week, if you want to do something other than these types of fractures, which are, as I said, are great for solid objects like stone and brick and cement and things like that. If you want to do wood or glass or those types of things, you can go find tutorials for that. As a matter of fact, I mean, I could just point you in the direction here. Let me see. If I go in here, if I right click, can I get this on screen? It's being cut off. There's a group down here called RBD. And in there is something called the RBD material fracture. That is a highly complex fracture node. And that fracture node allows you to do Voronoi fractures, but you can also easily change it to do glass fracturing and wood fracturing. But it is computationally intensive. So be careful if you want to try to experiment with those, especially if you use the wood preset. The wood preset really bogs your system down. So if you don't have a super powerful system, I would steer clear of it. So again, there's a lot of ways to achieve fractures on different materials, but for the sake of time, this is the only one we're covering. So again, keep in mind your content and the type of fracture shaping that you're doing here. All right, I think that brings me to importing geometry. So let me pause for a second, and I'm gonna go through this whole pipeline right out of Unreal. So let me pause for a second and find an appropriate Unreal Engine project. Okay, so I have Unreal Engine open. This is actually an ArtViz project, and this is using the real-time ray tracing. And this is just incredible in and of itself. I'm fortunate enough. I think I told everybody I've got an RTX 3090 card, so it handles these ray traced files, real-time ray traced files, very easily. Oh boy, there isn't really an object in here. Oh, maybe this could be a good fracture piece. That's ceramic, so that would make sense with a Voronoi fracture. So what I'm going to do is I'm going to find this in the content browser. So I'll come over here. There's the static mesh. So I'll just hit the find button and find it here in the content browser. Oh, there's a bunch of them. Actually, I think well, no, I'll use this one. All right, so I'll take this one. I wonder if this even has a collision mesh on it. Well, we'll see. So I'm going to right click on it. This is being cut off, but I'm going to go to Asset Actions and choose Export. Asset Actions Export. And I'll just put this, I'll put this in my project folder. So I'll go into my project and I'll just keep the name here. This SM means static mesh, and I'll hit save. And the FBX options come up, I'll just hit export. All right, and let me put that aside. And I have a new file here. So I'm going to use the method that I prefer, which is this. I'm going to create a new geometry node. And then I'll go into that geometry node and then do a import file. So I'll put down a file node and then I'll browse. Oh, this Houdini file is not, oh, you can't see it up here, but this new Houdini file is not in my project folder. I haven't saved it yet. So I want to do that before I import the object. So I'll do file, save as. I'll put this in here. I'll call this, let's just call this the UE4 import example. All right, so now when I hit the browse button and I browse by reference to the Houdini file, it will put me right there. There it is. Now this is going to come in really large. Oh, it does have collision mesh on it. So you see this big blue blob around it? That's the collision mesh. So we can do two things here. You either, well, actually the very first thing we need to do is we need to scale this down. Now this is a case where we want to scale up at the geometry level. So the problem here is this is where it gets really weird. So Houdini claims that it's in meters, but it's not. It's really in millimeters if you compare it to Maya and Unreal Engine. So it thinks it's in meters. So think about how large this object is. It's huge, and that will affect the characteristics of your simulation. So you need to bring it down to Houdini scale. And then when we export it, we have to take it back up from Houdini scale. So knowing that Houdini is technically millimeters compared to Unreal Engine, I want to bring my uniform scale down to 0.01, I believe. I think I want 0.01. The best way to test this is to put something like a box in the scene. So if I put a box in the scene, oh, and I went too small. Or maybe I didn't. So the box is 1 by 1 by 1. So according to Houdini, this is 1 meter by 1 meter by 1 meter. So I'm using that as a reference. Yeah, I think this is too small. So I went too low with that. I might want to go 0.1 instead of 0.01. There we go. That's better. So 0.1. Now I'm ready to go. So I always put a box in just as reference of what 1 meter is. All right, so now I can get rid of the box. Now what I need to do is I need to come into this geometry node and I need to remove the collision geometry. Now if you're going to re-export this and you want to keep the collision geometry but get it out of the way, what we can do is we can split the stream here. I can, let's see, I could put down a group node. How am I doing on time? I'm at 38 minutes. I could put down a group node. And if I put my display flag on this group node here, if you look at the base or the base group, you'll see it sees two objects. It sees the static mesh. This is being slightly cut off, which is the SM, that's static mesh. And then it sees a UCX. That's the collision geometry. So if you're making a model in Maya or Houdini and you want to make your own custom collision geometry, because Unreal Engine will make collision geometry on import for you. But if you want to make your own, you just need to make the collision geometry and then just make the prefix on it UCX underscore. And when you import that into Unreal, it will automatically read that as the collision geometry for that object. So I'm going to select that as the group. That's what I want in this group. And then, let's see, how do I want to do this? I still need to remove it. Yeah, okay, so then I'm going to remove it. Actually, I could just do a blast. I could do a blast node instead. Let's try that. I'm going to put down a blast node. And this might be easier. And in the blast node, I'm going to tell it to blast the collision geometry. And now I see the vase. Ooh, that vase is pretty high res. Oh, This probably, well, I've got a fairly powerful system, so I'll try it, but I wouldn't recommend something with this much geometry. I think all the objects that are in that scene that I was using are high res because that's supposed to be their photoreal, real-time ray tracing example, so everything is high res. Now, the great thing about Houdini is this blast node isn't permanent. So once we do our collision and, or not our collision, our fracturing and everything, and if we want to get this back into Unreal, we can just circumvent that blast node and export with the collision geometry again, because it's still there. You know, that's again what's great about the non-destructiveness of Houdini. If we were in Maya and we wanted to, we deleted the collision geometry, it's gone. We can't get it back unless we undo, and if we undo everything else we've done. So this is a great way to work. All right, so now what I can do is I can start building my fracture. I'm not going to go all the way through making a fracture out of this. This is the most important part, is how to get the model in here. Make sure you scale it down appropriately by scaling it against a 1 by 1 meter cube. And then you can start your simulation. But just for kicks here, let's see how well this dense model is handled. So I'm actually not going to do a volume scatter on this. I'm going to just do a scatter because it has it's a thin object anyway. So I'll put some scatter points on there, maybe 100 instead of 1,000. And then I'll run my Voronoi fracture. And let's see. See, it's taking a few seconds to cook because that geometry is fairly dense. Let's go ahead and just run a basic simulation on it and see how it works. So I'll put the null down. That's going to be my out. I always miss the capital on the T. Out, FRAC, FRAC for fracture. And let's see what happens here. So I'm not going to do glue or anything on this one. I just want to see how it performs. So I'll just do a straight RBD object. And then I'll also put down a ground plane for collisions. Oops, and the object is a little below the ground. So I could either move the ground plane down, or I could come back to my geometry node and just put a transform in here to move it up a little bit. This is being cut off, but I'm just adding the regular transform node. Yeah, see, even to just throw that node in there, I get a couple seconds of cooking. So you got to be really careful. And it's having trouble with me moving it. And I'm on a 10-core i9 with a 3090 card on it. Not that the 3090 card's doing anything right now, but not for this. All right, so now I have it lifted up a little bit. Probably went too far. Let's do 3. Yeah, so you can see this is a good example of staying away from really dense geometry. Okay, and let's see how my simulation speed works on this. Oh, it still simulates fast. That's not too bad. All right. Okay, so that's how we can get geometry in. So again, most important points here. Make a project folder, save your empty Houdini file into that folder, then put your imported objects in that folder, then import them into Houdini. And then make sure that you have the proper scale by scaling them against the 1 by 1 by 1 cube. Remember, that's 1 meter by 1 meter by 1 meter. So you want to make your object that size accordingly. All right, I think that's everything I wanted to cover here. So I'm going to stop the video now. Again, we're still planning on meeting at 1 today, unless that changes for me. So keep an eye on the announcements to see if we're going to meet if we're going to meet face to face or not. Right now we are, but I might have to cancel that. So hopefully I'll see everybody at 1 though.